I love it. It's where I really like it.
Oh, there we go.
Wrong one?
That was a Zoo one. Is that good? Yeah.
Yeah, that's better.
Oh. Thank you. That's all the instructions.
Good morning, everyone.
Good morning.
There we go.
My name is Nana Ousmanou. I have joined WSO National Office in Cameroon since 2019 as a Public Relations and External Officer. And since then, I've been working on to develop the sponsorship and the partnership of the organization at the level of Cameroon. I've also been working on developing the membership of the organization at the level of Cameroon. So since 2019, I've been an advocate of what WSO does around the world. And we are working tremendously every day to make the organization like wherever we go. So actually, I'm a safety engineer. I started my career in the oil and gas industry. I worked for 7 years, and since 2023, I decided to have a pause in my career. I moved to France to do an advanced master's in safety engineering and management. That's a 1-year program I've embarked in. That's 6 months tutorials and at the university, and 6 months to develop a project in a company or enterprise, whereby I'm going to develop a project in partnership with the company. So I decided to develop or work in the implementation of ISO 45001 occupational health and safety management system with EasyMile. EasyMile is a Toulouse-based company in France which develop autonomous vehicles for the transport of freight industry. So today I'm going to speak about or show or present to you how autonomous vehicle in the transport of freight system improves safety globally. So today I'm going to present to you this technology, the opportunities and challenges that this technology offers to everyone, and what are the opportunities in terms of safety performances. To develop this presentation, I'm going to go through key section that I'll give a brief introduction presentation of EasyMile, subject and stakes of this presentation, the opportunities and challenges of the product I'm going to present to you, and conclusion. What's EasyMile? EasyMile is a Toulouse-based company that develops software. That software is being used in the develop autonomous vehicle that is being used in the transportation of goods. Actually, EasyMile has developed level 4 autonomous system. This autonomous system is being used in the well-developed area or environment that is being embarked on the software or the written program is embarked in this autonomous vehicle to really to be operational in a specified area. Then, EasyMile has different representation. The headquarters being in Toulouse, representation in Denver in the United States, representation in Berlin in Germany, and another representation in Singapore. EasyMile developed 3 main products. We have the EasyTow, the EasyTop, and this Kamak. The EasyTow you can mainly find in airports around the world today, and we have a partnership with TLD, which is an American-based company, to develop this autonomous vehicle. You find the EasyTop here in ports, in big industries. You can also find this EasyTow in factories. Many airports in the United States today is implementing this EasyTow. You can find it all over Europe today where this EasyTow is being used. And this Kamak is being developed now in, you can find it in Switzerland and in Austria, whereby different companies or different ports are using these in their daily operations. Oh, we had a presentation of the vehicles. I don't know why it can't work. We can come back to the video at the end of the presentation. So, these vehicles normally, in their function, EasyMile develop what we call the software, the programming, and the intelligence behind these different products. And TLD develop the backbone, the vehicle. TFT developed the vehicle and give it back to EasyMile. EasyMile developed what we call the software, the intelligence behind to make this vehicle autonomous and safe for both the consumers and the operational or the workers developing this product. That's the same for all these products. We now move on to the subjects and states. Actually, these products brings about opportunities for the freight transport and also a lot of challenges. First, it reduces the number of accidents and improves safety by replacing human drivers. We know in the safety field today, a lot of incidents, when we come back to investigation, is due to human behavior. Today, implementing these autonomous products, it improves the performance of the company itself and reduce the number of incidents or accidents by replacing human drivers by autonomous systems. We have a lot of challenges to make this vehicle operational. That's the safety system behind needs to be a rigorous safety system, taking into account the environment where this vehicle is going to operate, the needs of the company in terms of performance of this vehicle, and every country or every continent whereby this vehicle has to operate has their own regulation. The regulations or the system that's going to be embarked in the vehicle is different in what they need in the United States and what they need in Europe. So the regulations and the legislation in different continents varies even from one country to another. So the companies make sure to develop the products that will be efficient and that will respond to both legislation and regulations needs. So this system is dynamic and changes from depending on the environment where this vehicle has to be implemented. We now go, as I said before, the regulation and infrastructure needs to be adapted, and now humans have to adapt. That's technology is really difficult to be adopted. We never want to change our behaviors. We really want to change. When we arrive in an airport, we really want to see our luggage, someone in the truck or driving. But now to adopt this technology, we need to put in mind that the vehicle can walk alone, the vehicle can do the job alone. That there's a really good challenge in the adoption of this technology, but with the tests and different pilot phases that have been done around the world, we saw that this technology is really working good and that can be adopted worldwide. Next, what are the opportunities? First opportunity, the reduction in number of accidents. We know that the autonomous sector or the production of autonomous vehicles is really new worldwide. So many countries around the world are moving in this era, but there's little or no studies about autonomous vehicles, their effects, and the number of accidents around this. The only data we could find in Europe is little, but in the US we could compare with different data compared to the sector. So we have practical data to demonstrate the efficiency. Airport and logistics, we couldn't find a lot of data in terms of accident related to autonomous vehicles. But in terms of the freight transport, the water transport vehicle, fuel tankers, pushback tractors, aviation security vehicle, catering service vehicle, and special vehicle, we could derive data and the number of accidents we could find in a year compared to the use of this autonomous vehicle, whereby the number of accidents considerably reduced, let it be in the port environment, in an industry or factory, or in the airport. The different airports whereby the pilot phase had been made, we could see the safety performance increase in the company or the airport. So we deemed it valuable to move into this autonomous vehicle adoption. We can find here that data derived from the US. We could see that 6 million car pollution had been made in 2023 in the US. 2 million people were injured. 37,000 people died in more than yearly. 94% of the fatalities that was being caused by human error. This technology for sure prevents human error because the technology behind was to make sure that the system in place reduce as much as possible what humans were reluctant or negligent about. Working on that has considerably reduced or will reduce the number of incidents we may have in this different sector we have highlighted. That's the transport or the transport in aviation, in the ports and industry and in our factories. How does this system improve safety by replacing human drivers? First of all, human-related accident factors are negligence, distraction, fatigue. These products autonomously address use cases where humans are expected to drive repeatedly on the same route for 6 to 8 hours. We can find in factories people that are working, doing the same job continuously for a shift, that's a shift of 6 to 8 hours, continuously doing the same thing. You are prompted to do errors because repetition, you develop reluctancy, you develop negligence. But this system does not develop, it's not reluctant to the number of hours it's been in operation. And for sure, this system can work 24, and 7/7 each day. It just needs maintenance and review monthly or every semester. Increased efficiency. Normally, with an autonomous vehicle, you don't have absence, you don't have lift for medical reasons, we don't have people quitting their jobs every day and night because they are not comfortable about the working conditions. You have an autonomous vehicle that's committed to do the operation for you. Whether you are good or not, you just need to be maintained. So we have operational efficiency that's being offered through this technology. Reduce cost. Long-term automation could potentially reduce labor costs associated with traditional freight transportation. Obviously, when you see in the port or with the CAMAC, that's mainly for big industry. You can find a truck driver that will tell you he may not do the job. He will obviously do the job for you in 48 hours. With these autonomous vehicles, he can work continuously and do the job for you in less than 48 hours. In terms of labor costs associated with the transportation of this goods, we obviously gain in terms of cash. So obviously, it's a good deal for the companies or industries to adopt this technology. And for sure, the technology is safe because there's a backbone behind that assures the system safety. And all of this product has been accredited both by ISO and different organizations around Europe and the United States so that this product is valuable to be implemented around the world. So each of the accreditation or certification to be given to this vehicle to operate in different environments has been given out because of the technology that has been developed behind that assures safety for the users and the environment around. Challenges. Obviously, there's a lot of challenges, especially in the development of the backbone of this system. To make sure that this system works, we have two main systems. That's the EasyDrive. The EasyDrive here is the technology behind the vehicle. There are two systems, the sensors, the radars, the GPS, the IMU, the cameras, and the lidars. That makes the backbone to make this vehicle autonomous. That's the different sensors we have as human to operate. We develop all these or put in place in the vehicle all these sensors that helps him to be intelligent, do what a human is trained to do. And the platform inside the vehicle, that's the traction, the braking system, the steering, and the accessory, we make it intelligent so that it can behave or react like a human. And there's a safety system in the vehicle. When the vehicle realizes there's something wrong, let it be in its environment, direct environment. In the production of this vehicle, there was a problem. Because at one moment, the vehicle found itself in an airport that was in Netherlands. There was grass that would always grow in the airport. The vehicle will always consider that grass as an obstacle. So we're always called for, there was always stops. The vehicle will stop, we need to reinitiate the program so that the vehicle could continue working. So what had to be done was to modify the system of the intelligence inside the vehicle so that the vehicle could understand that that grass is not really an obstacle. He could proceed his operation because it was not a barrier for him to conduct his task that was assigned to him. So we needed to develop, go back to the research and development team, try to incorporate this error or this environmental restriction in that airport to to make understand the vehicle that the grass around is normal, it's not an obstacle that could prevent the vehicle to continue its operation. So this technology is being developed continuously with the new obstacle or new barriers that could be presented along the way. Vehicles are constantly connected to the internet to ensure functionality, thus exposed to cybersecurity threats. These vehicles have a rigorous system to prevent cybersecurity threats because it's an open system that needs to be managed or we can work on in a long distance because there's a maintenance team that's based in France. Wherever this vehicle is, we can, from a long distance, do the maintenance on the vehicle. We are prompted for that, so we need to have a safety system behind to really make sure that this vehicle is safe. Let it be for the operation, during the operation and the people around and the equipment or system around. Also, the autonomous vehicle have a black box. In case of accident, data and images are recorded, are analyzed for remediation and prevention of further occurrence. That's very good in incident investigation. So far, we had one incident with the EasyMile that was in a factory, BMW in France. It's using this technology in their factory. So what happened is that the vehicle went through the gates while leaving the factory. So he arrived in front of the gate. He never had the usual stop. He proceeded through the gates. So that was an error. We needed to understand what happened to the vehicle because that's really a big problem because it could be a human in front. So we needed to understand what happened to the vehicle and what to understand that it's just like a black box in an airplane. We took the black box back to the office, do some analysis to understand, view the images of the incident, understand the programming of the vehicle at that stage. What was really happening in the system of the vehicle to understand. And from the analysis, we understood that the vehicle had a bug the day before, and that bug was not considered by the team in place in BMW because they are trained to really capture any fault being announced by the vehicle. So the operator in place in BMW did not capture the fault that was being pronounced by the vehicle. So what he did, he ignored it, and the effect of this ignorance was the incident had happened the next day. So what has been done is training back the team in place to make sure that every fault, and there's a procedure to remove faults or to remove an error from the vehicle. There's a procedure to be done in place. If not, push back to the operators in Toulouse to make sure that the fault is being corrected. So the fault was in the system of the vehicle. They had a bug in the radars. So the radars was having a bug, and this was due to weather condition the day before. That was during winter. The operation, the vehicle operated 24 by 24, 7 days in a month, during the month of January. And it happened beginning February. So the vehicle started having a bug due to weather condition, severe weather condition he has gone through over the month. So he started alerting the operators in place that something is wrong with my system, I need some maintenance. So this event or incident happened due to lack of maintenance from the operators in place. So what was done, training was given to them after this incident investigation, continuous maintenance or maintenance weekly overview or control of the system in place, and if there is a fault or error, do the checklist or the procedure in place. If not, you can succeed to move it to the operators or engineers based in Toulouse to do the job. If they can't do it overseas or from a distance, the operator or maintenance team will travel to the site and do the maintenance in place to make the vehicle operational. This vehicle has been working in BMW since 2020, and that was due to COVID. It helped a lot during COVID because they wanted to reduce the staff in place to make sure that production continues. So that's an example of what may happen due to the fault or bug of the system.
Sorry, can I just ask, if somebody was killed in that incident, right, so say for example you got the bug, the vehicle goes out and kills somebody,
Yes.
Who's responsible?
We are both responsible, both the technology developer and BMW, because we have a shared responsibilities between the operation of this vehicle. We are in contract with BMW, we leased to BMW, so we are shared responsibilities. After the investigation, we could determine at what level BMW is faulty and at what level EasyMile is faulty, because he's the owner of the product. He has the license to operate the product wherever this product is being operated.
You just said, what is your level of confidence in your software?
My level of confidence, should I give it in the 100%? I can say 95%.
You said you give 95%.
Yes.
Okay,
At 5% error, because you can't trust the technology.
Right.
100%. So I am confident with this technology at 95%, and 5% I give myself a limit of for an error or
And question number 2 for your reliability. How many times of testing did you
Actually, to do so, EasyMile went through different certifications, started by the quality management system ISO 9001, then went on to develop these different certifications: ISO 26262 functional safety, ISO 3691, ISO 13849, and all this has been certified by different bodies along Europe. And coming over to the deployment in the United States with our partners TLD, we went through different certification across board to make this to ensure the safety of this equipment, both in the factory, in airport where this deployment is being done, publicly and infrastructure. Penetration test here, we are talking about the test and validation that is being done on site before final signing of the contract. We need to make sure that the technology is working, the technology is respecting the environment that has been assigned to him, and make sure there's no bug or any fault. And if so, we do the correction before final deployment and release of the equipment on site. Encryption. Encryption here, we are talking about everything that has to be done to make this vehicle operational on the different side, make it reliable depending on the side where it's supposed to operate. And the threat in terms of intelligence, cyber security culture, and cyber secure by design. So from the design, we put in the cyber security, we put in all the backbone to ensure that this product is safe. In the effects, in the staff, we have a lot of cyber security engineers that are recruited around the world to make these systems safe. In Toulouse, the company has 30,000 different nationalities in the staff and 30,000 PhD holders. The rest is engineers. You can count only 10 people around for the administrative staff and the rest. So, intelligence behind to make this product safe. They hired the most qualified people around the world to make it functional, because that was a game changer. Autonomous vehicle sector is something to adopt the technology is very difficult because no one wants the change. So that was the owner of the company went on to, it was a big challenge for him to do so, and he knew he had to invest on people to make this reliable. So I think it's a reliable technology. To make it functional and make it operational in the US, it was a big challenge, and it's operational around different airports in the US. I will give them out at the end of the, you can see where this, you can move, you could be in an airplane, you see it moving alone, taking your luggage from the plane to the warehouse. So it's a good technology. And why I wanted to present it, because I saw how safe this product is and how it has reduced human incident or accident due to freight transport, and how it can make companies around the world efficient due to the performance, 24/24 performance of this vehicle. But nevertheless, this product needs supervision and training. So this is a training team, this is a training manager from Toulouse that went on to Bosch. This is a training that she's doing in Bosch. This is the training or supervision panel installed in the company after deployment of the vehicle. There are operators being trained
to make sure that this vehicle operates safely, and they can really supervise the vehicle, the part of the vehicle, the performance of the vehicle, and see where there is a threat or there is a fault in the vehicle. From the day one, the vehicle is in operation, to the day you stop the vehicle operation, we have data has been stored. So at each time there's an incident, we can retrace the functionality of this vehicle from the first day we are putting it into operation to the last day we are getting rid of the vehicle. There's a database whereby all this information is being stored in Toulouse. So at any time, the government, regulators, bodies can come back to us to understand maybe if there's an incident, what happened, where was the fault. So there's constant training, supervision from the Toulouse team and the team in place. To conclude, this product is so safe and can help develop the freight transport worldwide, reduce incident and accident around different sectors, from airport operation, in industries and factories, and in the big industries like in ports and the like. EasyMile had to do, it was a big challenge to develop a product that's not really known and make it interesting to consumers or people around the world. So it had to develop a product that can convince, and to convince you need to make it operational and reliable. So that was the challenge, and it has been taken care of. Thank you all for your time. Warehouse to another. That's what the vehicle does at Industre. So, first of all, we move 3 people from the staff. That's a reduction in the number of people that was doing this towing operation from one warehouse to another. We also look about the cost of sick leave, accidents. There were a lot of accidents before the operation of this autonomous vehicle, and the vehicles low down, that's a breakdown of the vehicles they were using before. That was having a cost on their operation. And it was also having a cost on the operation of the production of these vehicles at this factory. That's the time between the design, the production, and the delivery of the vehicle. There was a considerable amelioration in the production timeline of the vehicle due to the effectiveness of the movement of parts from one warehouse to another during the production line. So we now come to the return on investment. What's the cost of an easy tool? An easy tool basically can cost 100,000 euro. That's the cost of an easy tool. So if you come out with 100,000 euro, the cost, yes, 100,000 euro will give you what we call a guarantee of the functioning of this vehicle in a 5 years period. What we offer to you is constant maintenance. We are available, we make ourselves available 24/24 for the maintenance of this vehicle. There are operators that are dedicated to each client or consumers. In the return of investment, in a 2-year period from the calculations we made, the company comes back, he gets back what he invested in this vehicle. So from the 3rd year, he's making profits and reducing his loss in terms of staff, in terms of production time, effectiveness in the production of these vehicles, and timeline in the delivery of the vehicle, and reduce breakdown. And the cost of maintenance he was having with the vehicles he had before. He was deploying a lot of vehicles in the factory. Now he's using 3 easy tools compared to 10 tractor he was having before to do the same job. So we have reduced the maintenance of 10 vehicles to the maintenance of 3 vehicles. Taking into consideration the cost of the vehicle, you have maintenance offered for the 5 years period guarantee of the functioning of this vehicle. So it's a great return on investment when you see it in a long period of time. But you see the functioning and effectiveness of this vehicle from day one. You see how effective and reliable the equipment is for you. So the second question was on the
There's
sensor.
got 5 sensors,
Yeah.
and then you have the platforms, and I'm just wondering what the failure rates are for those.
Yeah, the sensors, that's these different sensors that make the vehicle to function effectively. So the question is the reliability of these sensors, right? So what poses a lot of problems and that the engineers and the energy department is constantly working on is the radar and the leader. That's where we can have the high failure rates of the sensors, the radar and the leader. Why the radar and the leader? Because these equipment are very sensitive to weather. They are very sensitive to weather, and we know this equipment is an outdoor equipment. Let it be in an airport, it's an outdoor equipment exposed to weather. Let it be in a factory, it's an outdoor equipment exposed to weather. So what we do is try to update, integrate new functionalities in the radar and the leader to make it more effective. The reliability of these two sensors is improved yearly because the energy department is working constantly to improve it. That's where this technology has a problem. But the reliability that the radar and leader now offers is considerable. And as I said, it's at 95%. But it's not to the best of the appreciation of the engineers because they think we can do more. Because weather condition is something unpredictable. We can't really predict weather. So weather can be harsh compared to what has been planned before. So they are constantly working to expose these two equipment to harsh conditions. That's where a pilot weather exposure or weather system has been developed in Toulouse at the industrial site to expose the vehicle during testing. Rain, harsh snow, to make this vehicle, to see how harsh this vehicle can support harsh weather conditions. I think the reliability is good, but improvements needs to be done more and more on the radar and leader. That's where we have a lot of problems in the operation of these vehicles.
So how about your consumer, how their sales are people saying, yes, we'd like to do this, or people hesitating still?
You know, the sector or the autonomous vehicle sector is a very difficult market because, as I said, adoption of technology, we need to convince, you need to make, nowadays CEOs or managers speak in terms of cash. What profit will I get behind this technology? Is it valuable for me to put in the technology in my company? That's where the problem lies, and you need to convince. What we do, we go to workshops, we go towards clients, try to present, we can give you out a prototype vehicle working in your company for some weeks, for some months, for you to see how reliable the equipment is, for you to be convinced. The problem with this technology is that you just need to convince one person, and when one person is convinced operational, the competitors will like to get it. That's what happened between BMW and Bosch. So BMW did a lot of publicity behind the implementation of this vehicle. Bosch came in to say, okay, I need to see what this vehicle does. How can you make it possible with my factory? That's how it happened. Changi Airport in Singapore, you can see this vehicle working in Singapore for long now. You can see it in the Netherlands. To accept this, for this technology to be accepted in the Netherlands was a very big battle. The EasyTow was operational there for more than a year before we got approval, and the operation was on our own cost. To get a client, you see what you invest, but when you just sell 2-3 of these products, you have a return on investment. So it's grab a client. We have developed something very new. I just want to share with you. It's confidential, though. It's
actually the other way around. The best way it was explained to me is, the guy says, the pile of rocks over there, we used to go over there and hire all kinds of people pick those rocks and bring them over here. He says, then we brought in a conveyor. So that's what used to become a lot of these autonomous vehicles leading to a conveyor. Because the biggest problem, the biggest success, I guess, they've had at moving this forward is they actually remove people out of the equation. So they give them dedicated roads, give them and there's nobody, because that's always been the challenge of, okay, what if this thing goes rogue or goes, has a bug and goes off and runs somebody over. But what they do is a lot of them, they build specific roads and lanes and that for these autonomous vehicles, and nobody's allowed to go on them. So So they're working like a conveyor system in their own little loop. And they work really well, but it's the clients that are actually asking for this, they're waiting for it. But yeah, there's always the question of people losing jobs. It's different.
I mean, I think in a closed system, these are going to be fantastic, right?
Yeah.
Like where you can control the environment, this stuff will work brilliantly. The problem we're still going to have is that human-machine interaction sort of space. So my question to you, do you have any ethicists that are employed as part of the organisation, thinking through your heuristics around what you can do in particular situations as you set up the software that's behind?
Can you repeat those?
So do you have any ethicists employed that work through the heuristics, i.e., you know, if you've got a bus of people here and you've got an old man here and a lady with a pusher over here, how they choose which way the vehicle goes and making some of those heuristic decisions that the software is going to have to make outside of the closed system?
Yeah. So during the development of the like, I take for example BMW. When you are developing the products or you are putting in place the backbone of the product to be deployed in BMW, the MPPB will give you the guidelines, will give you what you want, will give you the restricted areas or the areas where this vehicle has to function. You integrate it in the system, you do the testing, you have the vehicle has a path he has to follow. Now, if the vehicle can't decide to change the path he has to follow. Now, to do so, you need to integrate, change the integration of the commands you have put in the vehicle before to make it change his trajectory of path he has been assigned before. Does that respond to your question?
No, not really. So the issue, I understand all that, and as I said, in a closed system, I think this is really easy. Like, you know, because I can then say, like airports, perfect example, right?
Yeah.
Because the reality is airports restricted space. You can say who goes onto the airport supply and where they go in front of it. The wider challenge is when you move out into contested space, i.e. roads and other areas, public sector, that type of space. And that's fine, like this is going to happen, right? And we already, you know, we've seen this with some of the Tesla stuff, which kind of shows, so you're one on the right-hand side, I think the truck you were saying before that's going in there as part of it. My question is, like, this is coming, there's no way this is not going to come. People are going to see the money as part of it. My question for you, though, as a company, do you have ethicists? So people are thinking about the ethics of the way that decisions are being made by the software. Because ultimately, that's what's going to get you into trouble as a company. And that's the things where, you know, people think about it and go, well, how do I know? Like something's going to go wrong. Like this world we live in. How is that decision being made by software? And that's being programmed in by engineers at the moment, but it actually needs some ethical thinking around how those decisions are made. And so my question is, do you have people employed just to think about the ethics around what happens in particular situations?
Yeah, of course. There's someone that's only there for legislation, regulation, certification, for each deployment.
That's different. For legislation, regulation, totally get that, you'll need that. My question is somebody that is just thinking about the philosophical kind of questions about
Before it happens.
yeah, before it happens.
Before it happens.
Like what's a life worth? And is somebody's life worth more than others? And these are not things that we can actually answer, but it's kind of things that need to be thought about as you put it into these kind of virtual and AI and systems as part of the process.
To note that the vehicle is a level 4 autonomous vehicle. That's really operational in restricted areas that has been, is in a known area. That will not change for now. We have not moved to a different level. And in terms of ethics and the like, before any deployment, all the backbone in terms of taking care of people, taking care of the regulation, taking care of everything that surrounds the operation or the deployment of this vehicle. There are people that are assigned for that to prevent any foreseeable unpredicted events that may happen, to make sure that we are legally well placed to defend ourselves in case there's an incident, in case there's a malfunctioning of anything with the functioning of this vehicle. So there are people that make sure that the deployment or the operation of this vehicle may not be a cost for us in terms of legal aspect. So there are people working around. The deployment of a vehicle may take 6 months only in terms of contracts, in terms of paperwork and the like. From now, we develop a level 4 autonomous that's fully autonomous in a restricted area or in a known area. That's why for now we operate in airports, and industrial sites, and factories, in ports. For now, we are not operating in large environments like Tesla vehicles and the rest.
I mean, I'll talk about that.
Yeah. We have some interesting questions and things. It just makes us think even more and more. This was a great question from him, but we can also carry this on to one of our roundtables or something. We can bring that up. This would be some good questions because we have great examples of great people that are great thinkers. We are a thinking group, so this would be a great thing for us to talk about at a later date. So I want to thank him for his presentation.